This video is meant to help you review how to write the equation of a line, either because you're given a graph, you're given a slope and a point that the line must go through, or you're given 2 points. Before we start, we have to remember the 2 pieces of information that we need to write the equation of the line. The first is the slope, and the second is the y-intercept. We also have to remember how to write the equation of a line. All of our lines in this course are written in slope-intercept form, which, if we remember, is y equals mx plus b. We know that our slope is represented by the letter m, and our y-intercept is represented by the letter b. So we need those 2 pieces of our equation, and then we can put them into the formula to get the final answer. So this first question asks us to write an equation for the line that has a slope of 3 and goes through the point -2, -8. So right away we're given m, and the only piece of information we need to find is b. So we're given a point, and each point has an x-coordinate and a y-coordinate, as well as our m, right? Our slope is 3. So we can start by taking those 3 values and plugging them into our slope-intercept equation. So instead of y in my equation, I'm going to plug in a -8 equals, instead of m, I'm going to plug in the 3, and instead of x, I'm going to plug in the -2. Right? Then we add b, and we have to solve since we don't know what the y-intercept is. So when I go through this equation, I get -8 equals -6 plus b. Then, thinking back into how we solve an equation, we need the b to be the only thing on the right-hand side, so we need to move the -6. To move a negative number, we add it to both sides. -8 plus a +6 gives me -2 equals b. So now I have my slope. I know that my slope is 3. I have my y-intercept, which we just found out to be -2. And we take those 2 values and we substitute them back into the original equation. So our final answer would be y equals 3x plus a -2. Right? We also have learned that instead of adding a negative, we can subtract. So you could also write 3x minus 2 instead of 3x plus a -2. Whichever way you're most comfortable with is the way that you can write your final equation for your answer. The second way that we can write the equation of a line is if instead of a slope and a point, we're given a graph. So I have 2 different graphs here, and we're going to write the equations of both of these lines. We're going to start with the graph on the left. So we have the red line, and we're given 2 points on that line. The first point is -3, 2, and the second point is 0, 4. Again, the 2 pieces of information that we need to know to write the equation of our line is the slope and the y-intercept. Sometimes when you're given a graph, you can see the y-intercept because you can see exactly where the line goes through the y-axis. So we know right away that our line cuts through the y-axis at this second point. So that means that our y-intercept is the y value at that point, which is 4. So right away we know that our b value is 4. We don't even have to solve for that one. The second piece of information we need to know is the slope. We know that slope is commonly referred to as rise over run. So we can figure out how many units we must rise up and how many units we must run over to the right in order to get from our left point to our right point. So you can draw a little bit of a triangle, a right triangle, to connect your 2 points, and then you can count the units. So we're moving 2 units up to get from -3, 2 to 0, 4. And we're moving 3 units over to the right, also to get from -3, 2 to 0, 4. So that was easy. We can figure out that our slope is the rise over the run, which in this case would just be 2 over 3. Once we have both pieces of our equation that we need, right, we can write slope-intercept form, which is y equals mx plus b, and then substitute in the 2 values for m and b that we just found. So our final answer in this case would be y equals 2/3 times x plus 4. In our second example, you can't see the y-intercept from the graph, right? The line looks like it's decreasing very quickly, and at no point has it crossed through our y-axis. So in that case, we have to wait on finding the y-intercept because we can't see it, and instead we're going to start by finding the slope of our line. So again, I'm going to draw a triangle to connect my 2 points, and we're going to figure out the rise over the run. So if I start at the left point, which is -5, 0, I'm going to move down 3 units to get to -4, -3. So my rise for my slope is a -3 since we're moving down 3 units, and my run, I'm only moving over 1 unit to the right, so it would be -3 over a +1. So if we want, we can just say that the slope is -3. When we don't have the y-intercept because it's not shown to us on our graph, we can use the skills and the question that we just did before, right? When we were given the slope and a point on the line, we could use those, we could plug them into our slope-intercept form, and we can solve for the y-intercept. So I'm going to start out by writing y equals mx plus b. And when we did that in the previous example, we used an x value and a y value from one of the points. I'm just going to use the first point that's given to me, and I'm going to plug in those values. So my y-coordinate of that first point is a 0. The m is -3. The x is -5 plus b, the y-intercept that we haven't yet solved for. So when I simplify this, I get 0 equals 15 plus b. Again, we want to solve and have the b be the only thing on the right-hand side, so we need to move a +15. We know to do that, we need to subtract 15 from both sides. 0 minus 15 is -15, right, equals b. So our slope is -3, and our y-intercept is -15. Again, once you have both of those two pieces of information, you can go ahead and write your final answer. So our final answer for the second graph would be y equals -3x minus 15. Again, if you're more comfortable, you could write y equals -3x plus a -15, since our formula has plus b. If you want to add the negative value, that's perfectly fine as well. And then the last examples that we need to cover for writing the equation of a line is when we're given 2 points, but we're not given a graph to look at. When we have a graph, we can sometimes just find the y-intercept because we can see it visually. If we're given 2 points, we're going to need to solve like we just did in that second graph example. So we know that we need to find the slope, which is m, and the y-intercept, which is b. So we'll start out by trying to find the slope, and again, we can't use a triangle in our graph because we don't have one. So we have to go back and remember the formula for slope. So since it's rise over run, rise is up and down, that's our y-axis. So we want to take our y2 minus our y1. So that's taking the y-coordinate of the second point and subtracting the y-coordinate of our first point. So the y-coordinate of our second point is 3, minus the y-coordinate of our first point, which is 6. Then we're going to put that over our run. Our run is horizontal, so that's our x-axis. So we're going to take our x2 minus our x1. And again, that means we're going to take the x-coordinate of our second point, which is 0, and I want to subtract the x-coordinate of our first point, which is 3. We can simplify this to get our slope. So 3 minus 6 gives me a -3 in the numerator. 0 minus 3 gives me a -3 in the denominator. And if we simplify that, we find that our slope is just equal to 1. Once we have our slope, we can pick a point. I'm just going to choose the first point to make it easier. And we're going to try to solve for our y-intercept. So when we're solving for b, our y-intercept, we always start with our slope-intercept formula. So we start with y equals mx plus b. Again, for our y, we're going to use the y-coordinate of the point that we've chosen, which is 6. For m, we're going to use the slope that we just found, which is 1. For x, we use the x-coordinate of the point we chose, which is 3. And then we add b, our y-intercept. So I get 6 equals 1 times 3 is just 3 plus b. And then we need to move the 3 off of the right-hand side. Since it's a positive 3, we're going to subtract it from both sides. And 6 minus 3 is also 3. So when I solve, I get b equals 3. So I have my y-intercept to be 3 and my slope to be 1. Your job is to take those two pieces of information and then to write your final equation. So my final equation in this case is going to be y equals 1x plus 3. Okay, and we have one last example to really send the point home. We want to write an equation for a line. This time it has to go through the points 8, 2 and 2, 6. So again, we're going to start the same way that we did in the last example. We first need to find the slope. We're not given a graph, so we have to use our slope formula again. y2 minus y1 over x2 minus x1. So I plug in my y values, which are 6 minus 2, over my x values, which would be 2 minus 8, and I simplify that to get 4 over negative 6. So our slope's going to stay in a fraction, but we can always reduce it. Right, 4 and 6 are both even, so I can just divide them in half, and I get that my slope would be negative 2/3. You can either have the negative 2, or you can make it a 2 over a negative 3, whichever you prefer. Now to find our y-intercept, again, if we're not given a graph, we have to use a point and our slope. So I'm going to choose the first point. I'm going to rewrite my slope-intercept formula so that I'm set, and I'm going to plug in my values. So for my y, I'm going to use the y-coordinate of my point, which is 2, equals my slope for m, which is negative 2/3, times x, which is 8 in this case, plus b. So I need to go ahead and I need to simplify. So when I'm multiplying fractions, I'm going to make the 8 into a fraction by placing it over 1. And then we know that when we multiply fractions, we can multiply straight across. So that gives me a negative 16 over a positive 3 plus b. So we need to solve for b. We need to leave that to be the only thing on the right-hand side. So to get a negative 16/3 off of the right-hand side, we are going to add it. So we'll add 16/3 to both sides. Now we have a problem here, right, which is that we have a 2 and then we're trying to add a fraction. So you have two options. You can, one, change 16/3 into a decimal so that it makes it easier for you to add, or you can take 2 and you can change it into a fraction, right, with the common denominator of 3. So what I'm going to do is I'm going to change 2 into a fraction. If I want 2 to turn into a fraction over 3, right, I'm going to take 2 and I'm going to multiply it by 3. 2 times 3 is 6. That's going to give me my new numerator. Then when I add, right, 6 plus 16 gives me 22 over 3, and that's just my new value for b, my y-intercept. So sometimes it's inevitable, right? A lot of times if our slope is a fraction, our y-intercept tends to be a fraction as well. So now that I found my two values, again I go to my original y equals mx plus b equation and I insert my pieces. So I get y equals negative 2/3 x plus 22/3. If instead you had changed your fractions into a decimal, if you want to do this and check your work, right, you'd get y equals negative 0.67x plus 7.33.